Eric Markham wants to know in the Fringe FM chat if you're familiar with photographic techniques like zone focusing and using presets for exposure control.
Yes, I'm familiar with it. Zone focusing, that can be accomplished by setting the focus ring to a particular point, so it is focusing over specific distances. I'm familiar with the speed graphic cameras and the square grid that they had through which the operator would look to frame his photograph. The point about the Hasselblad cameras is that they didn't have any of that. The focusing ring on a Hasselblad camera is on the lens. The lens is a very, very good lens. It has very, very high resolution. It was made by Zeiss in East Germany. The focusing is done with little paddles which Hasselblad attached to the focus aperture and shutter speed ring so that they could be operated with armored gauntlets. If somebody thinks that I say something which is incorrect or wrong or factually inaccurate, please let me know. I want to know, because I don't want to continue to believe something which is not correct. And maybe I will make statements which people don't agree with, and maybe I will make statements which people think are completely ridiculous. Fine. Tell me. Don't attack me for saying them. Attack what I say. There's a difference between an ad hominem attack, I attack on the person, and attack on the information.
Okay, so one of the biggest things is the camera situation, right? And so Eric is stating that there was no reflex mirror to get out of the way. It wasn't a single lens reflex camera. Now you can respond to that and then the best you can, and then if we don't get any more information, then I guess we'll just leave that there. So what's your thoughts on that?
Okay, the Hasselblad camera is made by Victor Hasselblad of Sweden. The Hasselblad camera is still made today. You can go into a shop and buy one. It'll look very much like the Lunar cameras. It's basically a square box with, on one side of it, the lens which fits on. You can change the lens from a 60mm lens to 80mm, 150, 250 or 500mm lens. So you can change the lens. You can also change the magazine, which is on the back of the camera, and it is a single lens reflex. And that means very simply that it has a single lens. There is only one lump of glass on the front of the camera. A twin lens reflex will have two lenses, one that you look through and one that the light goes into to record on the film. I am talking about a film camera here, don't forget. So the Hasselblad camera is a single lens reflex camera, and you look through the viewfinder. If you're using it here on Earth, you look through the viewfinder, which is on top of the camera, and you look down into the viewfinder, and the light coming in through the lens is reflected up into the viewfinder by the mirror. That's why the mirror is there, it's to reflect the light. Once you press the shutter button to expose the film, the mirror has to move out of the way of the path of the light. And that is normally the click that you hear when you're using a Canon or a Nikon or any single lens reflex camera will have a mirror in it. The Hasselblad is a medium format camera. It's 70mm film, not 35mm film or 36mm film. It's the same size of film as is used in the IMAX cameras now, 70mm across the top. It's a square piece of film, and that moves through the magazine at the back of the camera. So yes, there is a mirror in a normal Hasselblad camera. On the Lunar Hasselblad cameras, the mirror was taken out because the astronaut could not get his head down to look through the viewfinder. So it was useless. They took it away. There was no need to have it. Now, there's a point that I think we should address right now about photographic film. Photographic film, which is what was used in these Hasselblad cameras, and also in the Maurer 16mm film cameras, which were also carried on Apollo, they were using photographic film to record the activity of the astronauts, in this case on Apollo 11. It was filmed out of the lunar module window, and it was set to shoot at 1 frame per second. the whole time the astronauts are on the lunar surface, which was 2 hours, 20 minutes, in the case of Apollo 11. Photographic film goes very brittle in a vacuum, and it becomes unusable. How do we know this? Right, there are two other spacecraft which used photographic film. One of them was the Hexagon spy satellite, the KH-9, was launched in 1970, carried through to 1986, launched several times. That used photographic film. The other one was the Lunar Orbiter, unmanned spacecraft sent to photograph potential landing sites for the Apollo missions. The Lunar Orbiter, 1966, 1967. There were 5 Lunar Orbiter missions. The Lunar Orbiter and the Hexagon used photographic film to take the pictures. The photographic film was housed in a container within the spacecraft which had to be kept pressurized. The pressurization was between 1 pound per square inch and 1.5 pound per square inch, i.e. not a great deal of pressure. The equivalent, incidentally, of pressurization in the atmosphere at about 60,000 feet. If it had to be kept pressurized in these two spacecraft which flew in the vacuum of space, so we're talking about vacuum here, here on Earth, where we stand, we have about 14.8 pound per square inch of atmospheric pressure pressing down on us from all sides. The higher up in the atmosphere you go, the less atmosphere there is, so the less pressure there is. And if you get to the top of Mount Everest, which is just under 30,000 feet, the atmospheric pressure there is about 5 pound per square inch, i.e. not very much, which is why people going into low pressure atmospheres have to take their own oxygen with them. It's not that there isn't any oxygen in the atmosphere at that height, there is. It's the pressure is not great enough to force it into our lungs. And that is why we have to take additional oxygen if we want to survive. So you get up into space where the space station is now, or even on the moon where the vacuum on the moon is so great, it's about 3 or 4 times greater than where the space station is, because bits of the atmosphere sort of float off and there is a little bit of atmosphere. Not a great deal, but there is a little bit. On the moon, there is no atmosphere. There is extreme vacuum. If you put photographic film into an extreme vacuum, it becomes so brittle, it will probably break. Now, having discovered this, I only discovered this about a year ago, just over a year ago, when I attended a lecture in London given by the designer of the camera for the Hexagon spy satellite. It was a highly classified system until about, I think it was 2011, it was declassified. So the designer of the camera was particularly proud of his work, and quite rightly too. It was a remarkable piece of equipment because it took stereo photographs so that they could measure the height of rockets and the size of buildings and the size of ships, because these spy satellites were orbiting across Russia, photographing all the things that they could find to see if they were building lots and lots of rockets or lots and lots of bombers. It was the Cold War, don't forget, this time.
That from my understanding, when it comes to the equipment and the tools and instruments that NASA uses, and I've studied this a little bit, but I don't know the specifics, but I do know that they are very apt to modify things, you know, cameras, equipment, things, to modify them so that they can be used. Has anybody ever asked you that about the cameras and stuff, about the equipment, and said, look, it was modified. I know things weren't designed this way, but we modified them to work. What would you say to that?
Oh, yes. Well, certainly, as far as the cameras are concerned, they were modified. If you compare a lunar replica camera, which I've handled, I've seen them. Hasselblad UK have one, which they'll lend out to you if you ask them very nicely. I've seen these. I photographed it myself. I use it in some of my presentations. They were modified. Now, a Hasselblad camera has what's called leatherette covering on the outside of the camera. That was removed, and the camera was painted a sort of aluminium-covered coating, allegedly to reflect the heat. It didn't do that, but that's what we're told it did. It had the mirror taken out, as I've already said. It had what's called a reso plate inserted between the camera body and the camera magazine. So every photograph taken on the lunar surface has these little crosshairs on them, which you'll supposedly be able to use to determine distances, because determining distance on the moon is difficult. There are no frames of reference. Well, that's what it would appear to be if we look at the photographs. But most of the photographs taken on the lunar surface, allegedly on the lunar surface, have these little crosshairs on them. So there were modifications. The shutter button is where it normally is on a Hasselblad, on the front of the camera, but it was much bigger. It was about 1 inch square, obviously, so that if you're wearing armored gauntlets, which they were with their spacesuits, they could presumably feel around the front of the camera, find out where the shutter button was and press it. Obviously they missed a few of them, so they had made a pistol grip, which mounted under the camera, and it, as the name implies, it was a pistol, like a pistol grip, right, where you pressed it, and that would then fire the shutter. But you couldn't see where the pistol grip was under the camera because it was hidden by the camera from your spacesuit. So how successful it was, I don't know, but the pictures obviously came out very, very well indeed. We've all seen them. They're very good pictures. No dispute about that at all. But were they taken on the lunar surface? I contend they were not.
When we're talking about radiation in the Van Allen belt, are you saying that a rocket can't pass that, or just specifically a human?
Now, this point about radiation, now rockets can go through radiation. You can't actually see it. It's part of the electromagnetic spectrum, but it's not visible light, so you can't actually see it. It doesn't stop a rocket, because we know the rockets have gone beyond the Van Allen radiation belts. Some of them gone to the moon even, and some have gone to Mars. And anytime you want to fire a rocket away from Earth, you have to go through these Van Allen belts. They start at about 600 miles above the Earth's surface, and they extend out to about 20,000, 25,000 miles. It depends on the amount of radiation that is being... It's accumulated from the sun and from galactic cosmic rays, i.e. deep space. We call them belts because they are held in place by the Earth's magnetic field, which, as we all know, points north. If you take your compass, what that is following the lines of magnetism generated inside the Earth by the iron core of the Earth. These lines of magnetism move out from the Earth, from the North and South poles, and they form, in effect, big belts around the Earth. And those are what protect the Earth from the dangers of radiation, because humans are very delicate little creatures. We're not designed to operate in radiation environments.
The projection of the radiation of the sun, there's a name for it, and it shows it in graphs as the Van Allen belt is going around, that energy going around it, or deflecting it, so to speak.
Yes. What it's deflecting is what's called the solar wind.
That's right.
And it's going in all directions. It's not just going towards Earth. Basically, the sun is like a giant light bulb, and it sends light out in all directions. It sends radiation out in all directions. And if it coming towards Earth, it is deflected by the Van Allen radiation belts. And that then flows around Earth and forms what's called a magnetotail, which extends out about 200,000 or 300,000 miles beyond Earth. And the moon sometimes moves into that. And that would be the time, if anybody wants to avoid the radiation, when the moon is moving into the Earth's magnetosphere. But the point is, you've got to get off Earth first. And in order to get off Earth, you have to pass through the Van Allen radiation belts. Somebody will say, no, you don't. You go through the North Pole and out the top. That's absolute rubbish. No, it's not rubbish to say that that's how you would avoid them, because you could. But you've got to launch your rocket out towards the North Pole in order to avoid the radiation belts. Now, in order to go through the North or the South Pole, the same thing would apply there. If you're going to launch a rocket to go through, over the North Pole, you have to set it on a certain trajectory to do so. It's quite possible to do that. And in fact, there are quite a few rockets which launch satellites, usually spy satellites, what's called a polar orbit, i.e. it goes from North Pole to South Pole. And as it orbits around the Earth, it can photograph the Earth as the Earth moves below it. And that's what the Hexagon spy satellite was doing. It was orbiting on a polar orbit and photographing Russia. But of course, we didn't tell them that we were photographing them because they got rather upset. So it was all done in great secrecy. And the photographs were taken in a polar orbit. Now, the Apollo craft, all of them were launched from Cape Canaveral, Cape Kennedy in Florida. And they headed out towards Africa on what I refer to as an equatorial orbit. Now, some people will disagree that it's not an equatorial orbit because it doesn't follow the equator the whole way around. No, it doesn't. It moves up and down around the equator, because most Apollo astronauts have actually said this, that when they launch, the first thing they look out for when they are launched over Africa is what's called the Eye of Africa, which is a remarkable formation in Mauritania. It's about 20 kilometers across, 15, 20 miles across, and it looks like a human eye. It's various rings. Some people have identified it as a possible location for that legendary Atlantis that we hear about. If you're launched from Cape Canaveral and you fly out over Mauritania, you're not on a polar orbit. You can't be. You're on an equatorial orbit. And for Apollo, we're told, right, they launched from Cape Canaveral, they went out over Africa, across India, across the Pacific, South America, and back round again. And then after 2.5 orbits, they launched to the moon. Well, of course they launched to the moon from an equatorial orbit because the moon is more or less straight ahead. Well, 3 days later, it'll be straight ahead on Apollo 11. If you fly out through a polar orbit, you're going to miss the moon, because changing direction in a rocket is not as simple as changing direction in a car. You can't just turn the steering wheel and go in a different direction. It's Newton's first law of motion. An object will be set in motion and remain in motion until acted upon by another force, i.e. a steering wheel. But rockets don't have steering wheels.